Welcome to the second part of Lesson 1, Area of Quadrilaterals. Today's video is especially for grade 9 elite students covering Term 1, Module 6, Lesson 1. We are going to finish the module Lesson 1, Area of Quadrilaterals in today's session. And as you see from the pictures, we are going to talk about kite, we are going to talk about rhombus. So let's dive into the video and see what you're learning today. In today's video, our learning objective would be to understand the difference between kites and rhombus or rhombi and to find the area of kites and rhombus. So let's do it. So first I want you to look at the pictures of the two. So the first one that you see here is kite and the second one that you see here is rhombus. So look at both of them, find the differences, find the similarities and tell me. Take a minute to observe and I hope you can see the markings that these two are equal and these two are equal. However, for the rhombus you see all are equal. The angles are all 90. So this is one basic difference and let's now summarize the key points. We can say rhombus is like a parallelogram. So if you take a parallelogram and make all sides equal, what you get is a rhombus. It's a parallelogram where all sides are equal. So AB, BC, CD and DA all are equal. Okay, so that's a rhombus for you. All the properties of parallelogram are going to be true for a rhombus also. Now for a kite, if you see here carefully, it is again a quadrilateral, but here not all sides are equal. There is a difference. These two sides are only equal, these two sides are only equal. So you can say it's a quadrilateral where two pairs of consecutive sides are equal, that is AB is equal to AD and CD is equal to BD. So that's what is true. Now it is not a parallelogram, as you can see. Kite is not a parallelogram, whereas rhombus is a parallelogram. So that's the difference between the two. So in today's video, let's find the area for both of them. So I want you to recall that a rhombus is a parallelogram with all four sides which are congruent or equal, and a kite is a quadrilateral with exactly two pairs of consecutive congruent sides. So congruent or equal length means same. So these markings show you what is equal and what is the similarity and difference in a rhombus and a kite. Even though both of them have some differences, the formula to find their area is the same. The area of a rhombus or a kite both can be found by this formula, which is 1/2 of the product of the length of the diagonal. So if the two diagonals are D1 and D2, the length are given as D1 and D2, then its area is equal to 1/2 D1 times D2. So even if it is a rhombus, even if it is a kite, if you have the length of the diagonals given, you can find its area. Now I want you to recall what is a diagonal. A diagonal connects opposite vertex. So if this one and this one opposite, you join them, that's one diagonal. This one opposite, join them, that's another diagonal. Similarly, diagonals in a kite are the opposite vertices joined by straight lines. Let's do a very simple question. Here you are given a rhombus. Half of the length of diagonal is given. So if this is 6, both are equal. So this is also 6. If this is 7, both are equal. So this is also 7. So what is the length of the diagonal? It's given that the diagonals of the rhombus bisect each other. Bisect means divide into two equal parts. So the length of the diagonals will be 6 plus 6, which is 12, and 7 plus 7, which is 14. So you have got both of the diagonals. So now you can find area 1/2 product of diagonals. So just plug in the values and get your answer. 12 times 14, unit is millimeter square. So divide, simplify, and your answer would come out to be on simplification as. So we can just do some calculation here. So this cuts here 6. So 6 multiplied by 14 would be your answer. Unit is millimeter. So when you do that calculation, your answer comes out to be 84 millimeter square as the area of the rhombus. Now the area of a kite. Now, this is a very simple question because you're already given the whole of the length of the diagonals. One diagonal is 16, the longer one, the smaller one is 9. And the formula you all know is 1 by 2 product of diagonals. So just multiply 16 with 9 inches square. So what does this come? It is 144 divided by 2 inches square, so which is equal to 72 inches square. So the area of this kite is 72 inches square. Let's solve another important question. Here you have to look at the units also, because you see that one diagonal is given to you in centimeters. The area is given to you in square inches. So you need to find the length of the other diagonal in inches rounded to the nearest 10. So unit conversion has to be done. Now remember, area is 1 by 2 d1 times d2. One diagonal is already given. Let the other be x. So x is what we need to find. This is a different kind of a question because area is already given to you. Area is 92 square inches. So you need to convert your units from centimeters to inches before you solve this question. So let's see what are the steps to solve in the next slide. Okay, so we know 1 inch is equal to 2.54 centimeters. That's the conversion factor. So I convert this diagonal length, which is given in centimeter, into inches, and it comes out to be 22 inches. Now it is easy. In step 2, we just plug in the formula. Your D1 is 22 inches. The unit is inches everywhere now. X you will need in inches. Area is already given to you in inches square. So you solve and your length of diagonal comes out to be 8.4 inches. Remember you to convert the unit, otherwise you will get wrong answer. So unit conversion is the important step of this question. So that brings us to the end of today's session. Coming up next on my channel would be Module 6, Lesson 2, Area of Regular Polygons. So stay glued, subscribe to the channel if you haven't still, press the bell icon so that you don't miss the upcoming videos. Like and share this video as much as you can if you found it useful, and do comment with your questions and queries. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye, students.